All right, trigonometric equation, sine x is equal to 1. From the previous video, we were looking for solutions to the equation where sine x was equal to 0. So in this case, we're going to mark those points on the graph where sine x is equal to 1. So those are the blue dots right here. So how do we know that sine x is equal to 1 right there? From the unit triangle, you may remember that the first occurrence when sine x is equal to 0 was not to 1 was 90 degree or pi over 2 radians. Okay, so this is where you may remember the unit circle. So this is the circle right here. Okay, x, y. So this is where your angle was measured from x-axis all the way up to here. So sine ratio, angle theta, is defined as y over r. So at this point right here, when you move from 0 all the way up to y-axis, y is equal to r. So the x-coordinate is gone. So for the unit circle, this is a point where you have 0, 1. A little bit messy. So you can appreciate now the ratio of pi over 2 or 90 degrees is equal to 1. Okay. So this is how we can justify that sine x is equal to 1 when x is equal to pi over 2. That's fine. Now, how do I know what is the value of the angle right here at this point? You may remember the period of this function, sine x, is equal to 2 pi radians. 2 pi. And this, the second blue dot on the left, is repeated 2 pi radians from the first blue dot. So this is 2 pi radians away. So if this is pi over 2 and you subtract 2 pi, what would you get? So this value will be negative 2. So pi over 2, let me show you, minus 2 pi will give me negative 3 over 2 pi. So this will be my root at negative 3 over 2 pi right here. So this equation has two roots when sine x is equal to 1 on the interval negative 2 pi to 2 pi. Always remember what your domain is. Okay, if it's negative 2 pi to 2 pi, then you will be listing roots from that interval only. So in that increasing order, 3 over 2 pi, negative 3 over 2 pi, of course, and positive pi over 2. Okay, so this is for that interval. Just remember, they may ask you to find general solution to that equation. So now we're going to define general solution. So keep in mind, this wave is completed on 2 pi radians. Every 2 pi radians you go up and down back to 0. So going to the right, when you add 2 pi, you will generate another point on the graph where y will be 1. So when we start with the first root pi over 2, we can say add multiples of 2 pi, so 2k pi. And this will take care of any root where sin x will be 1. K is element of I, any integer. So this will sort of give you the basic idea. What is the solution to the equation on the given interval? And later, how do you define general solution? Thank you for your attention.